Thank you for joining this webinar. I'm going to show you in about 30 minutes how you can do your own market segmentations. The general principles are applicable in any software, but I'll be demonstrating in Displayr as it's designed for presentation. With one little exception, everything I'm going to show you can be done in Q, and if it's not obvious how to do it in Q, just ask in question time and I'll show you how to do it. In the GoToWebinar app, there's a little field where you can type questions as we go. Now, there are two approaches to segmentation. You can use judgment to create segments, and that's not something I'm going to talk about at all today. Or you can use algorithms augmented with your judgment, which is what we're going to focus on. Once you've collected your data, there are 4 steps you need to go through and potentially 6 steps all in all. The first step is to prepare your data. How you do your data prep depends on a couple of things. It depends on what the data looks like, and it actually depends on what type of algorithm you're planning to use. I'll give you the opportunity to have a little read of this before I keep going. In the case study that we're going to work our way through first, I've got some satisfaction data I want to use. I've got 3 satisfaction variables. Now, currently these are ordinal variables or ordered categories. And to do segmentation, I generally need to convert them to being numeric. How you do this depends a little bit on which software you're using. So for example, in Displayr, you select the data, and you change the structure to numeric. The other thing I'm going to do is you need to check that the values are sensible. So in this case here, we've got the ordered categories, and we can see that the values increase with the increasing meaning of the categories. So that's promising. That's what we expect to see. But not answered's got a 0, and that doesn't really fit. And when we've got categories that don't fit, like a not answered or a don't know, we want to set these as missing values. Let's have a look at the raw data. And as you can see, we've converted our categories into numbers. So that's the first bit of the data preparation. This one's a bit more interesting. The text is showing why people said they liked their phone company in an open-ended question. So it's verbatim data. How should we convert that into numbers? Next week's webinar, which will be about text analysis, is going to go into detail. Here, I'm just going to more click on the buttons and not focus too much on how the mechanics are working. But what we want to do when we're preparing text data for segmentation is we generally want to use this nice little technique. It's quite advanced, so we're going to have to go through quite a few menus to find it. We're trying to do something called principal component analysis of text data. So I drag across my little text variable, which contains why people said they like. It's going to chug away, and the math is a little complicated, so it takes a while. So I'll show you one I've made before. Now, by default, Displayr has created 2 components. You can change this. It comes down to how granular the information is. The more information you want to extract, the more components you select. 2 will be fine for our purposes here. We then click Save Variables, Components, Dimensions, which is just going to add these variables to the file. And we've got to give them names just so we can interpret them a bit later. Now, the first one here is really people who said they liked nothing about their current phone company. And as I said, I'm going to in the next webinar get into a lot more detail about how this works. So apologies if I'm going a bit too fast here, because my goal isn't to describe how this technique works. It's just to say you can use this technique to convert text data to prepare it for segmentation. Now, and my second dimension here is that people didn't like service. Okay, so I've got 2 new dimensions. All right, so having prepared the data, we move on to step number 2. It's nice and prescriptive. We want to create 4 segments using latent class analysis. So how should you create segments in general? Well, ask Displayr. Type in the search box, It's going to highlight anything it wants us to know about, and it's telling us that, well, if we've got choice modeling or conjoint data, we should use latent class. If we've got max diff data, we should use latent class, but there are these other kind of options as well. And I'm telling you that we should always start by creating 4 segments, and we should always use latent class analysis. Why am I being so prescriptive? Well, most segmentations that get adopted tend to have 4 segments, so it's a great place to start. Why latent class analysis? Well, it's a much better algorithm. It's very closely related to k-means, but it solves a whole lot of problems. And the analogy to think about here is your car. You can go to a mechanic to get your car serviced, which is using latent class analysis, or you can service your own car, which will take your time. You might not have the skills to do properly, so you make some mistakes. So as I said, I always go with the latent class analysis first. Doesn't mean these other techniques are wrong by any means, and I'll come back to them a little bit later. So let's do it. We go into advanced analysis, into the cluster group, and we choose latent class analysis. We then have to select the data. I'm choosing the text data where we created those scores, the satisfaction, which we've already made numeric, and I've got some importance scores, and these are out of 100, showing how important people thought different attributes were. This actually comes out of a conjoint study, but it could just as easily have been rating scales, and I'll show you an example of rating scales a bit later. We could get Displayr to automatically work out the number of groups. It would do so using something called the Bayesian information criteria, which is the same thing as something called the AWE if using the 2-step in SPSS. The thing about these metrics are they're metrics people invented because people wanted a metric, but they're not actually in any sense valid metrics. And I'll talk about that in a little bit more detail. So we're going to change it to 4, but they're there if you want to do it automatically. All right, and then we have the output. And this output is actually one of the great regrets of my life because I had a poor engineer spend a long time building it. Sorry, Jan, but it's just not so good. Fortunately, customers gave us a lot of feedback about how they wanted to evaluate segmentations. And so we've got a specialty table designed just for it called the segment comparison table. And this exists in Q as well as Displayr. The way it works is we want to find out segmentation. Now, when we did the latent class analysis, it's automatically added a variable to our data file. And I just drag it and release it in the variable slot. And then I drag across the text data that was made numeric, the satisfaction and the importance data into the profiling variables. And I'm going to play around with a couple of formatting options just to make it a little easier for you guys to read it over the internet. Okay, so let's start evaluating our segmentation. The first thing we want to look at is, do we have between 3 to 8 segments? I'm not saying you must always have 3 to 8 segments, but most segmentations are in this range. When I say most, maybe 99.99. And we want the segments so that none are tiny and none are huge. Now, if you look here, our segments are varying from 9% to 49%. That is a fairly large variation. We would ideally like them all to be 25%, but that never happens in practice unless it's a problem. This varies a bit too much for my liking, but you can live with it, right? If these 9% are truly special in some way, and these 49% really are all very similar, then it could be okay. I'm going to put there may be a problem here as my first evaluation criteria. Now, the second criteria when we're evaluating a segmentation is, do we have segments that differ only due to response biases? And the answer is, I think, no for this segmentation, but I'll come back and explore this in a second case study with a bit more detail. Now, let's try and understand the differences between the segments. Now, the way that this table works is it's using black to indicate where there's statistically significant differences between the segments, and color to point out the size of the differences. So a blue bar is telling us, and this one's blue here, is telling us that the segment's much higher, a red much lower, and the length of the bar is showing proportional difference to the average. So segment 1, they've got a higher than average score in terms of having said that they like nothing in the verbatim data for why they like the phone company. They've got a higher than average score for saying they didn't like service. They've got well below average scores in terms of satisfaction, very unhappy. And so segment one, we can see that people are pretty unhappy with their phone company. Now, the other data we've used here is the importance data. And if you read down, you'll see that actually there's no bars here, not much significant difference. Basically, segment one are largely average in terms of every single aspect of what's important to them. And this gives us a problem because we've got a segment of people who are very unhappy, but they're average in terms of what they want. So it's not obvious to us how we can fix their unhappiness. And so that tells us that this is a bad segmentation. And the problem really is, in this case, we've tried to force together some data that just isn't telling a consistent story. Now, it's not a foregone conclusion that satisfaction data shouldn't be in here, but in this data set, it clearly hasn't fit very well. If for strategic reasons we really had to overlay satisfaction with importance data, we'd be better off creating two separate segmentations and then interlinking them later. So we're going to go back, we're going to modify our latent class analysis, and we are going to take out the satisfaction data and the text data about what people liked. And now Displayr will rerun it. And we'll go and look at the outputs. Let's look at the segment sizes. They're varying from 9% to 45%. So this is slightly smaller variation than before, but it's not great. It still might be a problem here. We've got one segment with only 25 people in it. Could they be outliers? I don't think they're going to be outliers. The 25 people have all said very similar things, which is the nature of what a segment is. Should we be doing a segmentation with segments with only 25 people in it? Look, it's not ideal, but if it's a small sample, and this sample here is about 292 people from memory, we can live with it. If we're doing a big important segmentation with a sample size in the thousands, we're really wanting to have about 200 people in each segment as an absolute minimum, or 100 people in the last, as a last resort, I think. But if we're just doing a value add like I am here, yeah, all right, 25, I can live with it. Now, we can see that even though the text data and the satisfaction data wasn't used to create the segments, we are getting some significant differences and some skews between the segments, which is good. In general, you want your segments to relate to other types of data. When we read down, segment one has got its highest score for streaming speed. Now, these importance data is out of 100. These guys, this segment of people, their average importance is just under 90, so that's pretty high. Thereafter, mobile data is the next most important thing. So got to come up with a name for them. I'm going to call this segment here the data hogs. Really like the data. Let's have a go at naming segment two. They've got a very high score for the quality of their voice calls, and they skew to that, so they're really big in voice quality. Actually, the high score is for price, but they are average for that because everybody's got a high score of price. And unlimited calls in the US, so this is American data, is very high as well. So I'm going to call these guys the big talkers. They clearly like to talk on the phone. Segment number three, this is our biggest segment. Their highest score is for price, and it's 97, right? That's 97 out of 100 on average. That's telling us that these guys are very similar, even though it's a big segment. And so we can be okay with it being a big segment. What else is important to them? Well, quality is at average of voice is important, unlimited calls is important. So they're kind of the cheap talkers. Segment number four. The interesting thing to note about this segment is it's got no super high scores. The highest score is 68 here, whereas all the other segments had scores in the high 80s and 90s. But they've actually got relatively high scores. They've got low scores on nothing at all, really. They're below average on some inevitably, but basically everything is kind of important to them. These guys need to be fully connected, right? They want voice, they want streaming, they want data, they want everything. Okay, let's go through and evaluate these segments. Again, we don't have any information on response biases. I think it's all good. We will return to this in the second case study. It was easy to name these segments. That's a great thing. It's a sure sign you've got a bad segmentation if it's hard to name. When you create a segmentation, it's important that it inspires strategies. A bit of a rookie mistake is to go, well, I'm the market researcher, I'll create the segments and I'll leave it for my clients to come up with strategies. But the reality is, if you as a researcher can't think of any strategies, your client's going to be stuffed as well. So what strategies can we come up with? Well, the cheap talkers, I'd be selling them discounted plans with a lot of voice. Data hogs, I'm selling them plans that are probably not going to be that cheap with really high unlimited streaming. So I can come up with plans, good, all good on this criteria. The next thing we wish to look at is there a strong relationship between the segmentation and other data? Now, we've already seen some relationship between the satisfaction data. It's a bit weak there. Let's bring across all the demographics and some other behavioral data and see what we can find. All right, let's scroll down a little and have a look. Okay, so looking at gender, there are some quite big differences here. The fully connected people are much more likely to be male. The big talkers are much more likely to be female, so I'm probably going to need to be a bit smarter about what name I give this segment. I might get into some trouble. If we look at the age data, we can see that the data hogs are nearly all under 45, whereas the big talkers much likely to be older, as are the cheap talkers, and that kind of makes a lot of sense. So we're seeing some quite big differences based on demographics. I won't keep exploring them because it would make the webinar a bit long and tedious, but relationship to demographics, we've got some strong relationships. We've got this last criteria, which we'll focus on now. So, as I mentioned, there are between 4 and 6 steps in doing a segmentation. Step number 4 is an optional one. It's to build a predictive model and, if necessarily, reevaluate your segmentation. I really want to stress, you only do this if you must do it. Do not treat this as a value add. Don't do it as something to do for free for your clients or your stakeholders. The reason for that is, as a general rule, predictive segmentations are bad in every other regard. There's a sacrifice. The better a segment can be predicted, the worse it is in terms of strategy and a whole lot of other factors. So you don't want to go down this path. But how would we actually do it? Well, let's say we're told we need to investigate a predictive model. Your default predictive model should always be, in my view, something with a majestic name of your random forest. I'll find it again, hidden away in a little machine learning menu, random forest. Why I love this model is it's kind of idiot proof, and I'm often a bit of an idiot. And even if you're not an idiot, it's still going to help you when you're in a rush because it's pretty foolproof. Obviously, nothing's completely foolproof. Now, our predictor variable, or thing, not predictor, our outcome variable is our latent class segments. We drag them to the outcome box. I'm going to build a predictive model based on some demographics and some behavioral data. And it shows me that my predictive accuracy is 44.52%. For those of you who love the technical stuff, this is an out of sample prediction, so it's kind of validated. The segment 1's 0% accuracy, segment 4's 4% accuracy, so this is not a good predictive model. If we were trying to build a predictive model from a segmentation perspective, we're really looking at 80% accuracy or better typically, and we may want as high as 95% depending on the context. I would stress this doesn't make this a bad predictive model for all purposes. There are many situations such as buying Facebook advertising, doing email segmentation, where you're very happy to have a segmentation model that's just marginally above chance, but not with segmentation typically. So we go back and we evaluate our model again and would say, well, no, we couldn't build a useful predictive model. That's a bit sad. Now, if we had a situation where a client had said they needed to build a predictive model, what we'd now do is we'd go about using segmentation variables that were known to be strongly related to demographics or behavioral data. So we might do a whole lot of crosstabs, do some automated statistical testing to find the best segmentation variables and only include them, which would ensure that the prediction or the predictive accuracy improved. A kind of a rookie mistake, and I say rookie, but a lot of people do this for a long time, and it's certainly a mistake, is to redo the segmentation but include the demographics and the behavioral data in the segmentation itself. And the reason it's a mistake is you always improve your predictive accuracy, but it's kind of circular logic, right? If you include age, you find that you can predict age based on age, which is not very inspiring, and you end up just having differences in your model relating to age. So it's always, in my experience, a bad approach. You're much better off just segmenting by age and not trying to trick your latent class or your cluster analysis if you're in that situation. Now, as I mentioned, there's some different approaches to segmentation, predictive models. Here I did it based on demographics and behavioral data. There's a third approach, which is to predict using the actual same variables that you did in the segmentation. And so the way you do this is you drag across, in this case here, our importance data as the predictors. And what we expect to see is much, much better predictive accuracy. Here it's up to 89 or basically 90%, and we could actually get it much higher if we played around with some things. And then what we want to do is we want to find which of the variables are the best predictors. Now it's showing us here that price and coverage are the two biggest and premium entertainment is the worst. And we're going to remove from our model any of the least significant predictors until we drop our predictive accuracy to below 80% or around 80%. So premium entertainment, we're just doing backwards stepwise selection for those of you that love your jargon. All right, so we'll rerun it without premium entertainment. And then the next worst predictor is unlimited calls to Canada. Where's that? And then the next worst predictor becomes mobile hotspot data allowance. And you'll see that predictive accuracy is still hovering above 80% and well above 80% really. And so with only 4 predictors, we've still got our predictive accuracy at about 81%. It goes down if I remove one more. And this tells us that we can allocate people to segment knowing only, allocate to segments reasonably accurately, knowing only the importance of these 4 dimensions. A little note warning here. The way you implement this is you create golden questions. It's a new set of questions where you just try and measure the importance of, say, these 4 things. Sometimes the answers you get are wildly inconsistent to how you measured them before. So there's a bit of, you've got to be a bit careful when using these golden questions approaches, but it suggests here we can allocate people based on a small number of questions, which is the whole purpose of golden questions. And why would you do that? Well, one reason you might do it is if you're trying to allocate people into segments from a qualitative recruiting stage, because you want to get people in each segment and do focus groups. Another approach or another reason to do it is you want to give your salespeople a tool so they can quickly allocate people into segments. And I'll talk a bit more about how to do that in a second. So we're up to step 5. And this is where all the time goes. You want to create lots of alternative segmentations and choose the one that's best. Now, we've already created 2 segmentations. We created one using the satisfaction data, the open-ended data, and the importance data, and then a better segmentation just using the importance data. We can play around with different variables and come up with more segmentations. So far, we've only looked at 4 segment solutions. We can look at any number, even as few as 2, many as 10 if we want, but generally, I recommend staying in the range of 3 to 8. We can play around with different algorithms. Now, as I said, latent class analysis is the best algorithm in general, but why not play with one of the other approaches as well? The goal is you want to come up with lots of alternative segmentations, and then you need to evaluate them. Now, some people want to get a machine to automatically choose the number of segments, but it can't. And the reason it can't is because the criteria that are important to us are things like, are the segments easy to name? Do they come up with good strategies? It's extremely hard to train a program to do that. And the Bayesian information criteria, for example, which is the most common way of automatically selecting segments, it doesn't take any of that into account. And it's technically, statistically even invalid to apply it for segmentation. It's developed for predictive models, and these kind of models entirely violate its assumptions. So use judgment. Create lots and lots of segmentations. Look, if you're just doing a little segmentation as a value add on a study for a client, fine, spend half an hour doing it like I've just shown you to do it. You get a reasonably good result. But if the whole purpose is to do segmentation, I'm spending weeks literally creating alternative segmentations, creating a big table, evaluating all the strengths and weaknesses, and doing workshop with my clients to work the way through them. That's how you need to approach it. As I said, there are from 4 to 6 steps in doing a segmentation. Step 6 is also an optional thing. If we built a predictive model, step 6 is to create a segment typing tool. And to illustrate what that is, I'm going to modify our predictive model just a little bit to make it more interesting. I'm going to put sex and age into it. Now, a segment typing tool is a mechanism that allows people to allocate people into segments. Other people to allocate them into segments, such as a focus group recruiter or your salespeople. Now, if you want to reallocate new samples into the segments, that's very easy to do in both Displayr and Q. You just import a revised data file. But if you want to create a little tool that other people can use, you can do that in Displayr, not in Q though. And the way you do it in Displayr is you click on your output and you go down now. Lovely data science team just create this tool for us this week. You click Create Simulator. You get this nice segment typing tool. So with its default settings, it's predicting that somebody is in segment 4 and there's a 96% probability that they're in segment 4. But let's imagine the person told us that price was really important. Let's imagine we knew they were female and we knew they were 45 or older. This tells us that they're in segment 3 with a 78% probability, and this segment is our cheap talker segment, if you remember from before. All right. Now, as I mentioned, there are 6 steps overall to doing segmentation. We're going to look at a second case study now. This is a fun case study. It's a little case study where the data has been provided by the good folk at Greenbook. With this segmentation, it's data about what people look for when they hire a market research company to do their market research work. So we're going to go through these steps. We're going to start with data preparation. Let's drag across the data, have a little look at it. Now, I'll give you a quick chance to read the types of categories here. And I'll emphasize here, there's actually quite a lot of variables here. We've got to scroll by here. So what have we got to do? Step 1, we've got to turn it into numeric data again. And we've got to look at the values and just check they're in a sensible order, and they are. So higher important is higher number, which is what I want to see. I've got missing data, I'm fine with that. Step 2, do the latent class analysis with 4 segments typically. Now, I am, to make a point easier for you to see, just going to choose 2 segments. Let's evaluate them. So we're now on to step 3. We do that nice little specialty table called the segment comparison table. And we drag across our new segmentation variable and our predictors. And I'll give you, let me just tweak the settings here so it's a little bit easier to read. I'll give you a chance to just try and figure out what the segments are telling us. All right, so now, do we have 3 to 8 segments? Clearly we don't. We've got 2 segments, but we forced it, and it can be appropriate to have 2. It's just pretty rare. They're roughly equal size. I'm going to put, we might have a problem here. Now let's try and interpret the segments. What you'll notice is segment 2 has got higher scores on everything, almost everything in segment 1. What could that mean? It could mean that segment 2, everything's important. And segment 1, they're just ambivalent. They're happy to have any market research supplier that comes along. Well, as somebody who's no longer in business as a market research supplier, I can tell you that segment didn't exist. If it was, maybe I'd still be a consultant. The reality is much more likely that the difference between segment 1 and segment 2 is that segment 2 are people that just like to tick 5s, and segment 1 that people are just not so keen to tick 5s. And that's what's known as a response bias. So we've got a problem here. Now, it happens to be the case that such response biases are extraordinarily common when you get people to rate things on surveys, no surprise, and we've long known how to fix the problem. It's quite straightforward. You take the variables, and you can do this in Q as well. We're just going to go into the ready-made formulas, and we are going to scale them so that they're standardized within case. And what that means is for each person, we're going to modify their data so it's got an average of 0 and a standard deviation of 1, which will make them comparable. All right, now I go back and I modify my latent class analysis. Get rid of the original importance data. Move across the standardized data. Now, importantly, when we do our evaluation, we don't want to evaluate the segments using the standardized data. That's a bit of a mistake, because when we standardize data, we're making a whole lot of assumptions, and they too could be wrong. We want to verify that using the original data, the segmentation is still interpretable and meaningful rather than the standardized data. And the good news we see here is we are seeing significant differences between the data after having removed this potential yay-saying bias, which is the technical name for this response bias. And we're seeing segments that kind of make a bit of sense. So segment 1, they're very concerned about lowest price, and they want to work with a previous client they're familiar with, who understands their business. So this segment's really low in commercial and transactional costs, and we've all got client relationships like that when we're consultants. And then segment 2, they're really interested in sophisticated research, high quality. They want best practice, latest data collection, latest statistical analysis. So they're really looking for sophisticated, really full data analysis type services. So we seem to have solved our response bias problem, which is good. We could go and evaluate all of the other criteria, but I won't do that. Hopefully you get the idea. But I'm going to return to something. Create 4 segments using latent class analysis. I've been telling people to use latent class analysis for a long time, and I keep coming across people who are still using cluster analysis. It drives me a little bit crazy, because it's just, to me, it's just using a broken tool. Now, I'm not saying you should never use cluster analysis. I'm just saying start with latent class, because it's just better. I'm going to give you an example. We're now going to use, and I'm going to do this in SPSS, because most people who love to use cluster analysis also love to use SPSS. And we're going to go into the Analyze menu, and we're going to start with Hierarchical cluster analysis. This is that same importance data. Click OK, bang. Nothing. Not enough valid cases to perform the cluster analysis. That's disappointing. Those of you that are technical SPSS gurus will know that there's a bit of a trick. If you've got a lot of missing data, you want to be using the k-means, and you want to be choosing this option called Exclude Cases Pairwise. That's going to solve my problem, isn't it? Bong, not enough cases to perform the analysis. Let's go back to Displayr and try and understand what has gone on here. If we look at this data in the data editor, we see we have a lot of missing data, a real lot of missing data. You see, what happened is when Green Book were doing this survey, they were concerned about questionnaire length, and so they asked people only 12 of the attributes to rate agreement with them. So each person's only seen a subset, so nobody's got complete data. And the way that SPSS's algorithms deal with this is they only do the segmentation based on people with complete data, and then they allocate people to segments based on what data is available. And so if nobody's got any data, those algorithms just fail. And my point is and was that when you use these older algorithms like k-means, you've just got to manually solve a lot of problems. Whereas we saw with the latent class analysis, it didn't bat an eyelid. It was quite happy to proceed with the data as it was. And so when you use these older techniques, you've just got much more work to do to avoid having a problem. I would also stress that if you really, truly must use k-means because it's like some kind of contract you've made with your God, well, the Displayr and Q version will actually still work with lots of missing data. They're a bit cleverer than the traditional algorithms. Cool. A lot we've gone through there, haven't we? So there's a lot more detail in an ebook if you want to download. This is an old picture. There's now a second edition. There's a bit more information in it. You can get it from the website. We'll send you a link because later this week, we're going to send you a recording of this webinar. What questions have you got? Please type any questions into the questions field and go to webinar and I'll get onto them. And we've already got a question here. Deirdre says, how do I extract the Bayesian information criteria so that I can evaluate my segmentation? Well, Deirdre, good question. Now, it used to be the case that there was no way to extract this information from within Displayr, although it's easy to find in Q. The way we do it is we click on the segmentation and then we go into, it's kind of hidden away. We've got to go into the diagnostic something, click analysis report. And here we'll find various things like log likelihood, the Bayesian information criteria, entropy, all that kind of stuff, if you're looking for those types of diagnostics. And similarly, if you're desperate to actually get Displayr or Q to automatically choose the number of segments, you can do so by just changing it to work out number of groups automatically. And Brian says, can you show me how to do it all in Q? Sure, Brian. So I've got my data. Here's my importance data. I want to restructure as numeric. I right click on it, go down, restructure data, make it numeric. I want to check the values. I can check the values. Everything is in order here. I want to do my segmentation. I go into the segments group and I choose latent class analysis. Now, all the same options. The form just looks different. I say all the same options. Actually, Q has got more sophisticated options, some very quite advanced technical options. Now, having written all this code myself, I understand it well. Didn't pour it across to Displayr because I don't think they're actually very useful in most situations, but they are here for the Q users. So this is a situation where Q's got a little bit more in it. I am now going to click OK. In this case here, we get that segments analysis report that we looked at before in Displayr. Okay, and I've got my segments. If I want to do a segment comparison table, just type into the search box and segment comparison table, and I select everything. I can do everything in Q exactly the same as Displayr, except I can't do that segment typing tool. Scott, hi, Scott, he says, my experience to date using text PCA as input into LCA is that it doesn't seem to make much difference to the segments found. Maybe my experience to date is doing this as too limited, or maybe the text variables I've been using haven't been sufficiently informative. Yeah, Scott, it's like anything, I think. If the text data is not interesting, then you're not going to find much in it. A lot of text data isn't that interesting, unfortunately. We think it's rich, but it's full of a lot of junk. So that's all I can say. No, it's not all I can say. And you know this better than me, Scott, but with any market research data, the more structured the data is, the more you're going to get what you're trying to learn. And so when we use techniques like conjoint or maxdiff, or even when we get people to rate importance, we're forcing people to give the data that we're trying to understand in the segmentation, so that data tends to perform better in segmentation. Text data, we leave it to the person to tell us what they want, and they're going to give us a whole lot of interesting stuff and a whole lot of garbage, and but the algorithm is going to still have the garbage in it when you do the PCA, and so it tends just to be less informative. Bernie, hello, Bernie, he says, can you export the typing tool to Excel as a formula of sorts? No, you can't. The formula is extraordinarily complicated for the model. Well, actually, that's a bit of exaggeration, but it's moderately complicated. There's not an automatic way of doing it for that algorithm, but, and I should say, but if we go back to the predictive model and I change this to, whoops, wrong predictive model, I change it from a random forest to cart, which is a much simpler model, I then will get something that I can just use the logic myself manually if I wish to. So you can see here, it says, all right, if they've got importance score was greater than 99 for price, they're going to be in segments 2 or 3. And if their score was above 86 for coverage, they're in segment 2. So this is creating exactly the type of rule you'd want to do, which you can just do as a series of if statements in Excel. If you change the output from the Sankey tree just to text, it gives it in a formula, not quite a formula, but a more obvious way that you could then turn into statements in Excel. Scott's back again. If I have an LCA segmentation, LCA, latent class analysis segmentation, I'm happy with, then an import new data, but do not update the tree. Are the new respondents allocated to those segments? Yes, they are, Scott. So once you've done your segmentation using latent class analysis, if you say got a tracking study and you want to update people, all you need to do is you just click this update button here, bring in your new data set. It'll give you an option about whether you want to update the segmentation or not. And if you say no, it will just assign people to the closest segment. And that is all the questions we've got. To all of our customers out there, thank you for being our customers. Thank you for asking questions. To our non-customers out there, hopefully you've seen something you like. Bye now.